Hello, my name is Alila.
My name is Chloe.
And my name is Miller.
And we would like to talk to you about a project called Intelli Wheelchair.
A problem that we are solving relates to motor neuron disease. My grandmother had motor neuron disease, which causes rapid muscle weakness. Motor neuron disease is the name given to the group of diseases in which the motor neurons undergo degeneration and die. Neurons are cells within the nervous system that transmit information to other nerve cells by using electrical impulses, so they are critical for everyday life. The reason we want to help people with MND is because my grandmother had MND and was slowly not able to move, speak, or swallow. After a few years, she passed away because of it. So we knew we had to find a way to help people who suffer from the disease.
Approximately 100,000 people get MND every year. So our invention will help many people. What causes it? Scientists are yet to find out. As MND affects many parts of the sufferers' lives, we have decided to focus on mobility. Our creative solution is to make a smart wheelchair so people with MND can move independently.
After some brainstorming, we thought we could use Siri via voice commands to control the wheelchair. One of our challenges was that some people who suffer from MND can't speak, so we realized this would not work as some users with severe MND would not be able to speak. So we researched more to try to find an alternative way for the person to operate the wheelchair. We discovered that an EEG, an electroencephalogram, is used to detect electrical impulses in the brain. We did further research and decided it was exactly what we needed to help control our wheelchair.
We use electrodes on an EEG headset to measure a person's concentration. The electrodes are conductors that carry an electrical current from a headset to a computer. This data is passed into a Raspberry Pi, which is a mini computer, which then tells the motor to move, and the motor moves the wheelchair. And now we will show you a video of how it works.
A ganglion is part of your brain. This is the open BCI ganglion, which is the EEG board that reads the signals from my brain. This headband has two sensors that read electrical signals from my brain. There are two clips on my ears, which are ground references to remove interference. On the screen, you can see that the signals from the EEG board representing electrical activity. The Raspberry Pi runs a Python web server to display a user interface. There are arrows showing forward, backwards, left, and right, which represent directions to move the wheelchair. When the user is not concentrating, the user interface cycles through the arrows. When the arrow representing the desired direction of movement is visible, the user will concentrate, which the EEG headset detects, and then moves in that direction. The Raspberry Pi controls the wheelchair motors, which will move the wheels based on the arrow that is highlighted.
The spacebar represents concentration, and the blue arrow is the wheelchair. So I'm going to concentrate on the backwards arrow. We'll go backwards.
Initially, when we tried it out, the EEG didn't work for us, but it worked for our mentor. After some testing, we realized this was because of the impedance, which the ability of your skin to conduct electrical signals must be high. The next week it worked for me, Alila, and our mentor Matt, but unfortunately not for Chloe. This problem is ongoing, and we are trying to connect the sensors to different spots on Chloe's head, hopefully make it work for her. You can then try it out on a wider range of people.
We have learned so many new things on this journey, including what an EEG headset is, how to use line code, Python, and JavaScript, what a Raspberry Pi is and how it works, and about motor neuron disease. We would not have been able to do so much without our mentor, Matt Good.
Thank you. Our project is Beat Bullying. My name's Hannah Spargo.
And I'm Bianca Rack.
And we're from Scotch College in Adelaide.
We decided to enter the Young ICT Explorers for the year division 3 and 4.
Our problem is bullying, and recently there's been an increase of cyberbullying. We created our device to stop people from being bullied and just to support them.
Why we chose this problem? Well, that's a good question. Bullying has a long-term physical and mental impact.
Our solution.
So we decided to make an app prototype, which you can't really see, So basically we made an app prototype. This is basically for people who have phones. So this is the home page, instructions for the app, instructions for the device, like a safety slogan. This is like the home page, like the main page. And then this is the recording, like
when you click on the S button, it will take you to the recording.
So we used live buttons, so they work. And yeah, we did it in Keynote.
We also made a bag tag for people who do have a phone. We printed it out. We printed it on the 3D printer up there, but unfortunately we lost that. So these were our designs in Maker's Empire. And we also had an idea later that we could make the inside hollow. So then we could put the electronics in there as well. So yeah. And we also made these buttons using makey things. And when you hold this, on Scratch we coded them to go onto the stopwatch when you click the S button, Kids Helpline when you click the K, and when you click the E, it goes on to 000.
So basically we called Kids Helpline, and that doesn't really prevent the bullying. I mean, it just supports people who have been bullied.
Our responses to your feedback. You gave us feedback to add electronics to our bag tag. So we thought that we would need a SIM to have mobile data. And so then if you were in a park, you could always use it.
We had a few bumps with privacy laws. So basically we're not really allowed by law to record people's voices without their permission, but we can do it in a public area, but a school's classified as a private area, which you can't record people. And we were walking around asking some people, like our deputy principal and our principal, for suggestions of what we could do. And our deputy principal basically said that we could do text-to-text dictation.
Voice-to-text dictation.
Oh, yeah.
And we asked the legal helpline, but they said that would still be against the law. So, yeah.
Every summer in Queensland, we have extreme weather events that bring a lot of rain. Queenslanders also love outdoor pools. When a pool floods, it can take weeks to clean using extra power for the filter, increased use of expensive pool chemicals, and a lot of time and effort. As we both learned last summer, you can't swim in a pool while it's being cleaned. This was a photo from our first team meeting to decide what we were going to do with our project. We chose a product name and our team name. After the meeting with our mentor, we had a pretty good idea of what we needed to do. These are the 7 major components of our project: solar panel, pump, 5-volt relay, ultrasonic sensor, 12-volt battery, Raspberry Pi, and the Python code. We found a Raspberry Pi project on the internet that used an ultrasonic sensor and started with that code. Following the wiring diagram, we had a working sensor. We altered the time delay between sensing cycles 30 seconds and our target sensing distance 7 centimeters. We then found a relay project and edited that code. Using the wiring diagram as a starting point, we soon had a simple working relay. We added the 2 bits of code together and set the Raspberry Pi to auto-start the D3000 code.
We used some 12-volt adapters to plug the solar panel in. The Raspberry Pi runs using a 12-volt USB adapter. The 12-volt pump is connected to the relay and battery. Using cable ties and tape, we put all of the bits into our box and made sure they wouldn't move too much. We used a drill to add holes for the sensor, water pipes, and main switch. Test 1.
Just filling up. It's not coming out. Yeah, because it takes a while.
Test 1 failed because the pump only works if the pump itself is in the water. Test 2.
Well, our sensor's turning on too early. Now, as you see, our water's now coming out, and our pump is in the water.
Test 2 failed because the sensor was set to the wrong height after our modifications. Test 3.
It's on. Turn the water off, Layla. Turn it off. Our deflator is finally working.
Test 3 was successful. Yes, we finally have a working deflator. After winning the Queensland Young ICT competition, we decided to improve our product. After a long search, we found a new box that would fit everything in. When we were testing the new box setup, we managed to set the Raspberry Pi and ultrasonic sensor on fire. We think it was some crossed wires. We bought a replacement Raspberry Pi Zero, and thankfully the program still worked. We also replaced the ultrasonic sensor and added a better pump and solar panel. To keep the box as neat as possible, we got rid of the breadboard and soldered all of the cables together. Soldering is really fun. One of the challenges was to fit everything in. The new pump was the wrong way around, but we managed to get it to fit using more flexible pipe. The Raspberry Pi Zero was a lot smaller, and getting rid of the breadboard also helped. This is our finished project, working in a real pool.
Oh no, my pool's overflowing. Well, luckily I have the Deflator 3000.
My project is called Medibot. Medibot is a medication reminder system using only voice. The purpose of Medibot is reminding old people like my great-grandmother to take the right pills at a scheduled time. Old people often have lots of different pills to take throughout the day. I wanted to make it voice recognition because I wanted to make it easy for old people to use this system. Often old people can't use keyboard or mouse. Also, I saw a couple of apps about medicine reminders requiring phone skills and data entry. Medibot only requires the user's voice. To build Medibot, I used lots of different technologies. I programmed it in JavaScript, used text-to-speech and speech-to-text libraries built into JavaScript and Chrome. I used HTML to connect it all together, used CSS to style it up, and I hosted it on NeoCities. To start, I made a new HTML file on my computer with Visual Studio Code. I read about the voice recognition and text-to-speech on the MDN website and the Stack Overflow website, and I got some help from my dad. Then I made the computer say some test speech. I wrote the code in an HTML file. Then I got the speech recognition working. Next, I put in the correct pills for my great-grandmother and worked out a script what Medibot would say. Then I coded the script into functions and added error handling just in case someone said something that it did not recognize. And then I tested it with family members and refined it, and then tested it with my great-grandmother and refined it even more. Now I'm going to demonstrate how Medibot works. By the way, I call my great-grandmother Bubby, which means grandmother in Czech. When Medibot is red, that means you do not speak, and when Medibot is green, speak. To make it work for this presentation, I'll be when Medibot, to make it work for this presentation, I'll be using the take pills now button. Here it goes.
Hello, Babby. Are you there and ready to take your pills? Please say yes.
Yes.
You need to take 1 amiodarone, 1 IDUR, 1 hiprexana furosemide. Say finished when you have taken them, or say again to hear the list of pills again.
Again.
You need to take 1 amiodarone, 1 IDUR, 1 hiprexana furosemide. Say finished when you have taken them, or say again to hear the list of pills again.
Finished.
Thank you for using Medibot.
Now I'm going to show you a video of testing Medibot for the first time with my great-grandma.
You there and ready to take your pills?
I am, yes. Yes.
Hello, baby.
You need to say
Are you
yes
there
one
and ready
time.
to take your pill? Hello, baby. Are you there and ready to take your pills? Please say yes.
Yes.
It contains heat-sensitive
Yes.
liquid crystals in a blend.
Yes.
Please say yes.
Yes.
You need to take 1 amiodarone, 1 IDUR, 1 hiprex. When you have taken them, or say again to hear the list of pills again.
Yes.
You have to say again.
Hello, baby. Are you there and ready to take your pills?
Yes.
Please say yes.
Yes. I am ready.
As you can see, the first version of Medibot was not that great. I worked hard to fix these problems. When I tried to test it with my great-grandma, the voice speed was too fast to follow for her. So I tried slowing the speed of the voice down by changing a parameter in the text-to-speech library. Before I added the improvement, Medibot only listened for the exact equal expression. For example, you had to say exactly yes when it was listening. When I tested Medibot with my great-grandma, she kept saying things like, yes, I'm ready, or yes. So I added a dot includes in the code so she could say things like, yes, I'm ready, and Medibot would take it as a yes because there was a yes somewhere in the sentence. When I tested it with my great-grandma, Barbie often spoke too early and Medibot did not hear. So I thought up some things that might help. Then it came to me. Change the screen color. So I use BG color red and BG color green, which will make the screen color change red when you're not supposed to speak and green when you're supposed to speak. Now I'm going to show you a video of what happened after the improvements.
Hello, Babby. Are you there and ready to take your pills? Please say yes.
Yes.
You need to take 1 amiodarone, 1 IDUR, 1 hiprex, 1 oroxine, 1 furosemide, 1 solifenacin, 1 spirectin, half a sachet of Movicol. Say finished when you have taken them, or say again to hear the list of pills again.
Finished.
Thank you for using Medibot.
As you can see, it was way easier for Barbie after the improvements.